So I'm going to introduce Multimodal Conversation, technical specification version 2.1. I'm Miran Choi. So the scope of this technical specification, first, it shows the technologies for analysis of text, speech, and other non-verbal components. So that's why we call this multimodal. So which are used in human-machine and machine-machine conversation. And also we define the functions and formats of input and output data of AI modules, composite AIMs, and AI workflow. Okay, so that's the complementing use cases. And the scope, another scope is to enable more human-like human-machine conversation, emulating human conversation in completeness and intensity. And by improving machines' conversational capabilities in the two main phases of conversation. One is to understand the meaning, and the other one is the generating a pertinent response. We pursue the naturalness of the conversation between the human and machine, or machine and machine. Okay, so this MMC specification specifies the data format and use cases. So I'll introduce some data formats and some use cases. First, among the data formats, I will show the speech descriptors and text descriptors. So first, speech descriptors. Okay, so the definition of speech descriptors is the data representation representing various features of a speech segment, including speaker identity, prosody, and additional vocal elements, including intention, whispery quality, or creaky voice. So you can see the syntax as in the JSON file. And the semantics, you can see what these speech descriptors consist of. So the semantics are first the speech features. So that's the characteristic elements extracted from the input speech, specifically pitch, tone, intonation, intensity, speed, emotion, and speech features. And then speech features is the neural network-based characteristic elements extracted from the input speech by neural networks. And pitch, and I think you know what, the tone and tone type, and those the others are all about the speech speech descriptors. So okay, so these are the meaning of the speech descriptors. Okay, and also there's a tone. Basic tones consist of formality, assertiveness, such as assertive, factual, hesitant, and register, conversational, or directive, and so on. So these categories also describe the types of speech features. Okay, so, and next one is I'll show you the text descriptors. So what are the text descriptors? So these are all presented in the MPI website. So text descriptors. So first, the definition is a data type representing an input text such as syntactic and semantic information. It results from natural language text analysis and consists of the following elements, such as POS tagging, any tagging, so that's the named entity tagging. POS is part of speech tagging, and dependency tagging, and SRL tagging, that's the semantic role labeling tagging. So meaning is a synonym of text descriptors. Okay, so we can use the meaning instead of text descriptors. The semantics show you the name of meaning and definition of meaning, and part of speech tagging, such as noun and verb. So you can see what kinds of part of speech is tagged to a word. And next one is named entity tagging, so such as person, organization, fruit, and mountains, and so on. And dependency tagging describes the structure of the sentence. So the structure between the dependence between some words, among words. The dependency indicates the structure of the sentence, such as subject, object, head of the relation, etc. And the SRL tagging is the semantic role labeling. So, for example, the agent indicates agent, location, and patient roles among the words in the sentence. Yes. And then I will introduce some use cases. First, I'll introduce the conversation with the personal status. Okay, so this is conversation with personal status. So this means you make a conversation with some emotion or your attitude, social or cognitive attitudes. So the machine can understand your emotion, for example, or the machine can generate the sentences as a response to the to your remarks with some emotion inside the sentence. So the functions, maybe we can see the reference architecture of the conversation with personal status with this diagram. So this diagram is based on the AI framework. So it consists of many AI modules. And outside, you can see the input. So because this is a multimodal conversation, you have the input as a visual and audio and text. And there's an input selection. You can select input if it is text or audio or visual. So there's from the input visual, you can see the visual scene description. So that's the analyzed into the visual object identification and also the audio visual alignment. So it aligns the input visual and input audio together. And then there is a speech recognition module that from the speech, it produces the recognized text. And then the next module is natural language understanding. So in this module, based on the physical object ID, and recognized text, it produces the meaning of the sentence. And the input speech also goes to the personal status extraction. In this module, the personal status, that is the emotion or social or cognitive status, are extracted. And then that's processed through the entity dialogue processing. And then the machine personal status will be produced from this AIM, and machine text is produced so that the output is produced after the personal status display. So that's how the machine can speak, or it can show his some avatar, photo avatar. So this is the use case of the conversation with personal status. And then, yeah, the operations are described here, so you can read later. There's IO data, something like input text, input speech, and output. And also the functions are described fully here. Okay. Okay, and next use case is the human car interaction. So this is between the connected car and human. Okay. So you also see the scope and the reference architecture. So the car analyze the outdoor audio and input text, and the video from the outdoor and the video indoor, and then using the visual scene description and audio scene description, the data are analyzed into the natural language understanding, so the machine can understand what the people say, and then it produces the meaning and some face descriptors and body descriptors. And also, this is similar to the previous use case. So you can see the personal status extraction. So you can understand what the human say with the emotion. And then through the entity dialog processing, you can generate the responses to the question or the conversation from the machine. So this is the output is the inter-HCI human and car interaction information, and the message goes to the autonomous motion subsystem, and through the personal status display, the response will be produced to the machine portable avatar. Okay. And the last use case is the unidirectional speech translation. Oops, sorry. So this is, I think the link is broken. So yeah, I think Mark will explain it, the personal status from now on. Thank you.
Yes, thanks, Miron. I'm going to share my screen now. Okay, here goes. Now, Miron was mentioning something called personal status multiple times. The point is that MPI needs some way of indicating emotions like angry, or cognitive states like confused, or social attitudes like polite. And all three of those are bunched together as personal status. The factors are the ones I just named: emotion, cognitive state, and social attitude. And each factor can be conveyed by modalities, including text, speech, face, and gestures. Any of those four can show your emotion or your cognitive state, etc. In the future, we might consider other modalities for expression like body posture. And within a given modality, you have the factors analyzed and interpreted by descriptors. So for example, when you're using speech, the elements can be expressed by combinations of prosody, meaning pitch and rhythm, and volume, or other speech effects like degrees of tension of the voice or breathiness, and by vocal gestures like laughing or sobbing or burping. Going ahead, we're going to show you now what we mean. We'll have two tables for each of these factors: emotion, for cognitive state, and social attitudes. And what are those tables? The first one is just a set of labels. You'll have when we're talking about emotions, for instance, you'll have a categories column in the table where one of the categories will be anger. Then there will be a general adjectival column, including labels like angry, and then more specific subcases, a special kind of anger called furious, meaning very angry. But also we need to be defining the semantics of these different labels. So we'll have a table for that too. So for example, the gloss or the explanation for angry will be, quote, emotion due to perception of physical or emotional damage or threat. Now, what claims are we making for these labels and these semantic descriptions? No scientific claims. What we're providing is a convenience, a collection that we have made at MPI of these factors, these emotions, these cognitive states, these social attitudes. And the collection is intended to be useful, but we've also provided ways for you to modify or replace this collection if you have a different collection you like better. So here is just a summary of what I've just told you. The emotion, cognitive state, and social attitudes break down into the codes that describe them. In the case of emotion, you've got the version of emotion listings that you're referring to, and emotion values through text, through speech, through face, through gesture, and a fused emotion value that puts all four of those modalities together to give you one emotion, and so on for cognitive state and social attitude. So let's look at the label sets. As I told you, one of the factors is cognitive state, and their interest is our fourth category down. The adjective that goes with it is interested, but there are several different subtypes of interested, like fascinated or curious or bored. Likewise for surprise, as a category, the adjective would be surprised, with a D at the end, and the specific types of surprise would be astounded or startled. We want to know what those labels mean. So let's look at surprise, number 18, here in this second table that shows the semantics of the labels. Number 18, surprise is glossed as, quote, cognitive state due to violation of expectation. Where did these definitions come from? We invented them. We intend them to be useful, but if you don't think so, you can replace them with others. There's a procedure for that. But here you see the semantics of other cognitive states, like bored, meaning not interested, bewildered or puzzled, meaning high degree of incomprehension, and so on and so forth. And as we've done for cognitive states just now, we have basic emotion label sets. So I mentioned anger as a category, angry as an adjective that goes with it, and this subcases like furious, irritated, or frustrated. Under the category of fear, we have fearful or scared, and the subtypes would be terrified or just anxious or uneasy. And as in the case of the cognitive states, we want to define what we mean. So for instance, angry is, as I said before, an emotion due to perception of physical or emotional damage or threat. But furious, number 15 down here, as a subtype of anger is high degree of angry. Let's look at embarrassed, number 12. This is an emotion of shame due to consciousness of violation of social conventions. Sometimes it's a little difficult to tease apart whether a label should be called an emotion or a cognitive state. Surprised is an example, but we do the best we can. We also have some discussion of how we define emotion and cognitive state. And here's the third factor, social attitudes. We have an attitude of cooperation, for instance, and the adjectives going with cooperation are cooperative or agreeable and uncooperative. The subtypes of cooperation are flexible, subversive, or undermining, meaning you're trying to um, damage the cooperative situation. Uncommunicative, stubborn, disagreeable. And the definitions or semantics that go with these things, for instance, would be, let's look at argumentative, number 6. That would mean a social attitude of tending to argue or dispute. Let's look at boastful, number 11. That is tending to praise or promote oneself. We know somebody like that. So having taken a first look at these factors, let's look at the web related to them. And over here we have, wait for it, the personal status extraction, which tries to figure out, based on these various modes, what the emotion, what the cognitive state, what the attitude would be. And we have a diagram showing these factors, like the text, like the speech, like the face, like the body, coming in on the left, and various processing modules that finally deliver a single personal status. They would be description and interpretation of the text, likewise for the speech, likewise the face and the body, and then a multiplexer or combiner that puts all of these different modalities together and comes out with a personal status showing that you're angry, or angry and confused, or angry and confused and uncooperative. We have the technical description of the extraction for your reading offline, and the functions of the various AI modules that play their parts in the story that I've just been telling you. Feel free to go to the web and take a look at these. Let me go back to my PowerPoint. Let's see. Where was I? Over here, because we also mentioned something that Miran took a first look at, and this is text and speech translation, a specialty of mine. The diagram here shows the pipeline that is most familiar for speech translation. You have speech recognition, turning the speech that comes in into text. Then you have the text to text translation. There's a misspelling here, which we can see even sideways. And but that translation takes English text and turns it into Spanish or French or Japanese text. And then that translated text that in the target language will be pronounced by a text-to-speech module and coming out as translated speech. So I say, good afternoon, and the output is buongiorno or bonjour or konnichiwa. Now, one additional interesting thing is that we can describe some of the features of the input speech, and we can use those features to compose the translated speech. We can try to capture the voice quality, the voice color, so that the output voice is the same as the input voice, but in the foreign language. So just as I was giving examples a moment ago, in my marked voice, I say, how are you? And in Spanish, I say, ¿Cómo estás? But it's Mark's voice that's coming out. We have all of the elements, the input-output elements described, the modules that I just described for you and their technical descriptions, and so on. And I think that I have told you what I have to, and we'll pass you back to Leonardo now.
Okay, thank you, Mark. So let me move to my screen then. I'm sorry, but I'll get it there. Okay, now finally let me share. So this is about what the group is currently working on. So we have a significant amount of reference software that we have to clean up and publish. It will be published as open source so that you would be able to use it in the form of modules and also workflows. Then we are also working on conformance testing. So conformance testing is a critical element in standards, in the sense that if you want to plug in a component from a third party into our or into someone else's implementation, well, we must make sure that the two are able to talk to one another. So we are designing the elements for deciding whether something is conforming or not. And then we have a performance assessment. Well, this is quite a challenging point in the sense that, right, I have downloaded a module, and indeed it plugs in, it works. But you know, the performance is variable. I would like to have another one that works well. So we need somebody able to tell me, oh, this one is graded 4 or graded 25, whatever it is, that would be specified in the performance assessment document. And finally, we also wanted to explore the relationship of the AI workflow, in general, the AI framework model with large language model, because what we are providing with an AEM, it is the starting point of something that can be further improved. So with that, we are looking forward to working with you on this exciting Empire project, because I mean, of course, we could only present it to you a small part of the many things that we are doing, but I think that you should have a good idea now. And you should join MPAI, share the fun, and build the future, which is our motto. Thank you very much. Now I think that we can stop the recording.